Hello everyone, I welcome you all in the next lecture of IIT JEE Mains PYQ series. In this video lecture, I'll discuss two questions from year 2022. Okay, so without further ado, let's get started. So what question says, let A x belongs to R such that satisfy this inequality. It means A is the collection of those real numbers which satisfy this inequality, and B is the another set with collection of all those real numbers which satisfy this inequality, and we need to choose which one of the following statement is not true. Okay, A minus B equals to open minus 1 to 1, B minus A equals to R minus open 3 minus 1, A intersection B is to be itna, and A in B equal to this one. Okay, now so for A, what I will do, I need to find explicitly the set A, what exactly it is looking. So I'll solve this inequality, mod of x plus 1 less than 2. Before solving this inequality, I want to recall something. Mod of f of x, if we have this condition, mod of f of x less than a, then the value of f of x has to be in between minus a to a. So same thing we have here. Okay, what we have, this x plus 1 has to be in between minus 2 to 2. So this means x has to be in between minus 3 to 1. It implies that what the set A actually looking? Minus 3 to 1. This is your set A. Now, for B, how B is looking? What is B? How B is defined? Mod of x minus 1 greater than or equal to 2. Okay. So what it says, mod of x minus 1 greater than or equal to 2. And one more thing I need to recall here again. If you have f of x, mod of f of x, and it is greater than or equal to some real number, then it means that this f of x has to be in between minus infinity to a or minus a. Okay, and a to f of x up to infinity. Clear? I think you understand this thing. Now, here observe, mod of x minus 1 greater than or equal to 2. What it implies? It implies that x minus 1 has to be in between minus 2 to infinity, minus infinity. Okay, so what is our x? X is actually minus 1 to or x minus 1 this is, we can add 3 to infinity. Okay, this one we get. So here if we are combining both the results, what we get? X belongs to minus infinity to minus 1 union 3 to infinity. Minus into minus 1 union 3 to infinity. Okay, this is your set B. What is our set B actually looking? Minus infinity to minus 1 union 3 to infinity. Okay, now so our first option is, what is the first option? I'll write here. And what is our A set? Actually this is our A set, this is our this is our B set. What is our A set? A set is minus 3 to minus 1, open minus 3 to 1. Okay, now so from here I need to find, now first option is A minus B, and we are looking for wrong option. This thing you need to keep in mind, wrong option, which one is not true. A minus B, so this is our real line, minus infinity, minus 3, minus 1, 1 and 3. So I'll mark here, wait, Now minus into minus 1, this is your set minus 1 minus 1 including 1 also, and from 3 to infinity, this is your infinity, this one complete. Now and from a is from here to here, okay. And observe that what is our a minus b? A minus b is the collection of those elements of a which are not in b. It means x, actually we need to do this thing, we need to remove all those elements of which are common from set a. We need to remove from the set a those elements which are common in between a and b. And which are common? Here these are the common elements, these are the common elements. C minus 1 is also included in b. So a minus b will be open minus 1 to 1. It means that this option is true. Hence, if this option is true, it means it is wrong. We will not select this one. Second, what we have? B minus a. Observe that B minus a. Here I will do it again. Okay, no problem. Wait, I will make different one. Here we have this thing minus 3 to 1. Here, yeah, this one. Now, for B minus a we have again a different one. B minus a is the collection of those elements which are common between a and b. Okay, we need to remove from the set b. So it is minus infinity. This is your minus 3, minus 1, 1, 3 and infinity. Okay, so here we can observe that. Here we can observe that set B, what is set B? Set B is from minus infinity to minus 1 and from 3 to infinity, from 3 to infinity. Okay. After that what we have? Minus 1 to, what is our A set? A set is minus 3 to 1. Okay. And what we do? B minus A. B minus A means this is our common part. Actually only. This one is the common part. So it means, and so B minus A means exactly, B minus A means from here to here and from here to here. This one we need to take, this one only. Okay. So it will be minus infinity to minus 3 open union 3 to infinity. This is your B minus A. B minus A. It means that R minus close minus 3 to 3. Okay. Wait, one more thing. Minus into minus 1. Okay. And we need to remove open minus 3. It means 3 we need to include here. Minus 3 we need to include here. And here we have open 1. Here we have 3. It means 3 we need to include here. It means R minus open minus 3 to 3. This is your set actually. Okay. So here we can observe. But it is 3 to minus 1. Actually it is representation is wrong. So the option B is the only incorrect one. Okay. Because why I am saying only word? Why I am using only word? Because it is a single correct option. Okay. It is a MCQ. It is single correct option. Single correct. If it is single correct, then it means that if you go to answer, then we need to move on the next one. Okay. Immediately. If MSQ we have, then in MSQ we need to check all the 4 options A, B, C, D, like that. Okay. If this question came in MSQ, then we need to do same thing. Third we need to check, fourth we need to check. That's your homework. You need to check third one and fourth one. Actually third and fourth both are true. Okay, that's why we need to discard them. Okay. Now the next question is, this is our next question. What it says, set A is defined from 1, 2, 3, 4, 5, 6, 7 and B set is 3, 6, 7, 9, collection of those elements. Then the number of elements in the set, this set we need to find. Okay. Actually, let us assume that this set is T and it is the collection of those subsets of A. It is the collection of those subsets of A such that C intersection B has to be non-empty. Okay. Set T. T is the collection of those subsets of A whose intersection with B is empty, non-empty. Okay. So instead, one way is, first way is we will find like possibility of C will be 3, 6, 7, 9, 1, 3, 1, 7, 1, 6, 1, 9. But observe that if we are doing like that, then it will take a lot of time. Okay, very lengthy process, very lengthy, because first in our mind this thing will come. Okay, if we are not in touch with the exactly what we need to do, if we are not in touch with that, how we can calculate, how we can use a complement property, then we are doing like that, and will take very time, so much time. Okay, so another method alter is there. What we can do, first of all, number of subsets of A, exactly. Number of subsets of A is 2 raised to the power 7. I assume it is first equation. Okay. Now, what I am doing, listen. Set B you have 3, 6, 7, 9 it contain. So, I'll choose from the set A, I'll make another set, say set W, and it contains 1, 2, 4, and 5, because 3, 6, 7 is there. Okay. What I will do here, I am trying to collect all those subsets whose intersection with B is empty. That means I want to collect all those subsets of A. I want to collect all those subsets of A, that is C, such that C intersection B is empty. Okay. Okay. So how we can collect? We actually they are, how many they are in numbers? Actually they are in numbers 2 raised to the power 4. Okay. Because 2 raised to the power 4 is this number, is the number in which if I am taking any set, if I am taking any set, that interaction with the B has to be empty. Okay. So what I will do? So number of subsets of A, number of subsets of A for which their interaction with set B is non-empty will be 2 raised to the power 7 minus 2 raised to the power 4, because from the complete set I need to subtract all those for which it will came empty. Okay. Hence, if we are solving this one, what is 2 raised to the power 7? 2 raised to the power 7 came, 2 raised to the power 6 is 64, 128 will came. This is 128, and today 4 to 16, what we get? 112. Okay, so this is our answer, 112. What 112 is the answer, 112. Okay, I hope you understand this thing. What we did in this question, actually two ways are there. First of all, I will directly try to find the complete set T. Okay, but it is very difficult to find like that. Okay, and it is very lengthy. Not we can say typical, but it is very lengthy to find. Okay, so what we can do, instead of that, I'll try to find, I'm writing here total number of subsets. From the total number of subsets, I need to remove all those for which it came empty. I need to remove all those C for which the interaction with B is empty. So, and how many they are exactly the C? With 2 raised to the power 4, because they are forming from the 1, 2, 4, 5 elements by using 1, 2, 4, 5, because any subset of W, that is C, interaction with B always empty. That's why I'll collect all those subsets of W, that is 2 raised to the power 4 we already know, and hence we will subtract from the complete collection of sets and we get 112. So I hope you understand this concept. If you have any doubt, then you can do comments. Thank you for watching.